Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into a truly fascinating GitHub project, a nonlinear optics sandbox. It's like a playground for light, but way cooler. Imagine controlling light waves with an adaptive lens, all in real time.
Whoa, that sounds intense. So what exactly is this sandbox doing? Is it just pretty pictures? Or is there some serious science behind it?
Oh, there's serious science, my friend. It's a real-time simulator of coupled optical fields, fundamental and second harmonic, interacting with a medium you can control. Think of it as a superpowered, GPU-accelerated version of those classic physics simulations, but with light.
Coupled optical fields. Okay, I'm following, sort of. So how does the control work? Is it like magic?
Not quite magic, but close. They use an ADAM optimizer to adjust the spatial distribution of the optical properties of the medium. Refractive index, nonlinearities, the whole shebang. Is the feedback loop. The simulation runs, the optimizer sees the results, and tweaks the medium to get closer to a desired outcome.
An ADAM optimizer? Sounds like some serious machine learning is involved. So what kind of nonlinear optical effects are we talking about here?
Oh, the whole shebang. Kerr effect, Chi 2, and Chi 3. Nonlinearities, birefringence. The works. They even model Fresnel reflection and boundary damping realistically. It's incredibly detailed.
Wow, that's a lot of physics packed into one little sandbox. What's the point of all this, though? What are they hoping to achieve?
Well, it's not just about pretty pictures, although the visualizations are stunning. The goal is to understand how to control complex nonlinear systems. By studying the patterns in this optical system, they hope to gain insights applicable to other complex systems, not just optics. It's a clever approach to a very difficult problem.
I see. So it's a kind of analogical model, using optics to understand other complex systems. Clever. But, isn't it computationally expensive to simulate all these effects in real time?
That's where the GPU acceleration comes in. It's all done using WebGL, making it surprisingly efficient. The simulation runs smoothly, even with all those nonlinear effects. It's quite impressive. The code is even open source, so you can check it out yourself.
Open source, you say? I might just have to take a peek. This sounds like a fantastic resource for anyone studying nonlinear dynamics, or even just anyone who appreciates a really cool visualization. So what are the key components of this simulation?
There's the nonlinear wave simulator itself, which uses a leapfrog-like time-stepping scheme. Then there's the adaptive lens optimization, which uses the ADAM optimizer to adjust the parameters of the medium. And finally, there's the user interface, which lets you tweak parameters and visualize the results in real time.
It sounds incredibly well designed. The fact that they've broken it down into modular components is really smart. Makes it easier to understand, modify, and potentially adapt for other applications. Impressive.
Absolutely. The modularity is a key strength. The simulator itself could even be adapted for use in other projects. It's not just a pretty face. It's a powerful tool.
This has been a fantastic overview. I'm definitely going to check out the live demo and the GitHub repository. Thanks for sharing this.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Remember to check out the link in the show notes. Until next time, goodbye.
Bye-bye.